The National Eye Institute, celebrating 50 years of advances in vision research. NEI, leading the fight against blindness. Video shows blue sky with moving clouds, people's faces with view focused on their eyes, an adult and child reading, and cars driving over a bridge. Dr. Joan Miller, Harvard Medical School.
We are a very visual society, and so much of what we do depends on being able to see. Recognizing faces of loved ones, being able to read, being able to drive, which is so much of our independence. People are really afraid of losing that. It strikes at something that is very essentially human.
The National Eye Institute, views of the National Institutes of Health. Dr. Jeremy Nathans, Johns Hopkins University School of Medicine.
Well, the National Eye Institute is the heart and soul of vision research in this country.
Dr. Paul SIEVING, Director, National Eye Institute.
The mission of the National Eye Institute is to protect and prolong the vision of the American people and people around the world. We do this by conducting research to understand and treat eye disease.
Dr. Nathans.
Every American citizen is a shareholder in the National Eye Institute. It's working for us and it's improving our vision.
Crowds of people walking, then a girl wearing glasses. Dr. Rachel Bishop, National Eye Institute.
Some of the most basic interventions we now use for eye disease exist because of research that was supported by the National Eye Institute.
The beginning. Dr. SIEVING, black and white illustration of Congress in session.
The National Eye Institute was founded by an act of Congress in 1968.
A portion of the congressional bill. Group photos including Dr. Carl Kupfer, and an overhead view of NIH from the 1960s.
Dr. Carl Kupfer was the first director of the National Eye Institute, and he had the formidable challenge of designing an institute from the ground up.
Dr. Joram Piatigorsky, National Eye Institute.
Very exciting at that time to be in the Eye Institute at the very ground roots.
Early photo of Dr. GERALD Chater and two colleagues. Dr. GERALD Chater, University of Southern California.
We thought we were doing good for humanity, for individuals.
Dr. Piatigorsky.
There was a sense of academic freedom. There was a sense of exchange where people were talking to each other. There was a sense of learning.
Early photo of Dr. Piatigorsky in laboratory.
All kinds of new techniques of tremendous hope.
Dr. SIEVING, a doctor applying eye drops to a man, and early treatment tools, including instruments from a diabetic retinopathy study.
At the time the Eye Institute was founded, the major diseases that caused vision loss were glaucoma and cataracts, age-related macular degeneration, or AMD, and diabetic retinopathy.
The book titled Cataract and Its Treatment by Henry Kirkpatrick, M.B., followed by View of an Eye.
Among these, only cataract could actually be treated. Now, the big four conditions all have remarkable treatments.
From the laboratory to the exam room, Dr. Robert WURTZ, National Eye Institute.
I think the major thing is vision is incredibly important.
Illustration of open eye, which zooms in to show cells.
When you have problems with it, the consequences are catastrophic. The only way you're going to deal with these are by doing basic research. And that's what the Eye Institute does.
Dr. Eve Higginbotham, Perelman School of Medicine, University of Pennsylvania.
Basic science is a window for researchers to look into the very minute windows of the body.
Dr. Chater, animation of a leafless tree with spread branches. In the middle is basic research. To the bottom right is applied research. Treatment appears as multiple red circles all around the tree.
Without the basic research, there ultimately can be few, if any, clinical trials and treatments and cures.
Dr. SIEVING, samples are removed from a storage freezer. A scientist conducting an experiment.
One of the major successes for vision research is the story of anti-VEGF treatment for vascular diseases that affect the retina.
A clear view of two boys are shown illustrating normal vision. The image becomes blurred and patches are blacked out, illustrating diabetic retinopathy. The image becomes blurry and out of focus with the center obscured, illustrating age-related macular degeneration.
These include diabetic retinopathy and age-related macular degeneration.
Early video of an eyeball, close-up view of various people's eyes with the words Factor X covering them, followed by animation of blood vessel growth and cancer cells. Dr. Miller.
Back in the 40s, Michelson and others had realized there was this factor X that somehow was coming out of the retina that led to abnormal blood vessels growing. People searched for factor X for decades. Judah Folkman had come up with the idea that blood vessel growth drove cancer. So the ophthalmology group were trying to apply the basic principles that have been developed in cancer to issues in eye diseases.
Animated eyeballs showing normal VEGF levels. Multiple circles representing a protein appear to show high VEGF levels.
Well, in the late 80s and early 90s, researchers had identified a protein that did interesting things. This factor, when you introduced it, would cause all kinds of leakage and swelling, and that was clearly of interest to the eye people.
Early photos of Dr. Joan Miller with colleagues.
So a group of us really set to work to see whether this VEGF or VEGF could be factor X.
Animated diagrams showing normal VEGF levels in layered format. From bottom to top, blood vessels, pigment epithelium, photoreceptors, bipolar cells, and ganglion cells. When VEGF is injected, abnormal blood vessels grow into the pigment epithelium, distorting the retina.
We were able to show the amount of VEGF really correlated with the severity of abnormal blood vessels. Also, if you injected VEGF into normal eyes, you'd get abnormal blood vessels. So that was really exciting. We thought, wow, we may have found factor X, hard as that is to believe. Maybe there is one factor that is such an important driver of abnormal blood vessels in these different diseases.
Animation of cell with VEGF receptors collecting VEGF, then anti-VEGF treatments appear and intercept the VEGF before they reach the VEGF receptors.
And we were really ready to go to patients, seeking to see whether we could come up with a drug that would work to block VEGF and be useful in eye disease.
The basic research tree with applied research and treatment is shown again with full leaves and appearing healthy.
And we're able to show these anti-VEGF drugs were effective. When it actually proved to be effective in patients in the large clinical trials, it's one of the most exciting things that's ever happened to me in my professional life.
Dr. SIEVING.
Anti-VEGF drugs have led to tremendous improvements for patient care. This treatment rescues the vision. It improves their quality of life, and it substantially reduces the economic burden on the healthcare system.
Dr. Miller. People receiving eye exams and close-up views of people's faces.
It was tremendously exciting to be present through the early stages, going from the questions and looking after patients without great treatments, and then doing the studies where you start to see these tantalizing changes and then actually come up with a treatment that is used in 1 million patients around the world every year. It's just hard to comprehend. We still pinch ourselves, I think, with that one.
It's only the beginning. A laboratory with microscopes and scientists conducting experiments. Dr. Andrew Huberman, Stanford University School of Medicine.
There's a huge urgency for treatment of eye disease. And, I feel like we can't work fast enough or hard enough.
Dr. KAPIL BHARTI, National Eye Institute.
What do I want to tell the patients? I want to tell them that we are working hard to get to a treatment for them. What we are doing is not magic. It's a very careful, very thought-through process, and we go through it very rigorously to make sure that it's going to work, and we'll get there.
Dr. Nathans.
Nature does not give up her secrets easily. And each time you find a little bit of the truth, each time you pull back the veil just a little bit, it's a wonderful feeling. We need steady, thoughtful support for eye research, and that can come only from the National Eye Institute.
To learn more, visit nei.nih.gov. Logo for NIH, National Eye Institute.